In college algebra today, we worked with more sets of numbers. And we have a problem here, number 5, with a set of numbers. So maybe hit pause and sort them into the correct sets. All right, I'm going to go ahead and I'm going to go one number at a time. So -9, natural and whole numbers do not have negatives. So it can't be in those, but it is an integer. No decimals or fractions for integers. You can write -9 as a fraction, so it is rational, and all the numbers we're working with are real numbers, so really that whole set goes on that bottom line down there. -1.3, well, it can be written as a fraction, so it is rational. Like, if you want to write it as a fraction, you could write it like this. But integers, whole and natural, they have no decimals or fractions, and it is real. The next one, 0, it's a few more of the sets. It's not natural, but it is a whole number. Go off your notes for that. Whole numbers include 0, natural numbers does not. It is an integer because it's not a decimal. It is rational because you can have 0 of something, and it's real. Next, 0.3 repeating. Well, since it has a pattern, it's rational. Go with that idea. Yes, it's a fraction because 0.3 repeating is 1/3, but sometimes that's hard to see. Go with the concept that 3 is repeating, so it's rational. If there's a pattern, it's rational. And it is real. Pi over 2. So first off, pi is irrational. So I can't make an irrational number rational. So yes, it is a fraction, but if I half pi, it's still irrational. But it is real. Remember, they're all real numbers. Square root of 9 is a trick question because square root of 9 is 3. So it's all of them except irrational. And then lastly, square root of 10. For that, let's look at the calculator, because some people don't know what I mean by perfect square. So if I have a calculator and I do square root of 9, I get a whole number. I get 3. If I do square root of 10, I get a never-ending decimal. The calculator rounded that. If I highlight it, it goes longer. And it's actually infinite with no pattern at all. So that's why we want to say irrational when we square root a number that is not a perfect square. And that's it. We'll have a quiz over that on Thursday. Let's try out some other types of symbols. So first off, some vocabulary. Any number in a set is called an element. Below this, I show you set notation. That's this. I already said that on Friday. But what I'm worried about is that you know how to identify or communicate what x less than 6 is. So I would also be okay with you writing it like this. Or notice it's a counting number. I think the best way to write this is the smallest x could be is 1, 2, 3, 4, or up to 5. That was a bad bracket. Let's try again. There we go. So the main idea with the set notation thing is I need to know that you know how to read it and communicate what it's saying. So if you realize it's talking about 1, 2, 3, 4, and 5, then you're good to go. All right, a hard part is knowing the difference between intersect and union. So at the top of the page, we have a new symbol that looks like a different language. This is an intersect symbol. Another word for it is and. Another word for it could be both. But we want to write any number in both sets. The reason why they use the word intersect is because you could use that word. We want to write any number that is intersecting in both sets. But, I don't know, both seems to make more sense to most people. So when you see that arch, we are skimming through both sets of numbers and we're going to copy down a number that falls in both. So the number 8 is in both and the number 10. And that's it. It is possible that there's just no answer. There's no number that fall in both. And that's what this is talking about. So no number is in both. You could just end with that. You could write it with words. Or there's a really simple symbol. Draw a circle with a line through it. And that means empty set. The next symbol, I think it's easier to remember because it's a U. You know, the arch up there, the intersect, that arch doesn't really, I don't know, it doesn't really imply anything. But the U, for me at least, when I learned it, that does imply union. Another word is or another word is combine. I want to put all the numbers from one set and another set together. And that's the joining. Maybe that could be another word is join, but combine, I think combine covers it. So let's do that for number 3. I want to take the first set, union second set. So what I do is I start by copying all the numbers in the first one. And then I skim through the second set and write a number that hasn't occurred yet. 6 hasn't yet, and 12 hasn't yet. And I got it. If you accidentally repeat a number, if you, for example, write 8 twice, I won't take points off. But you do have to represent every number. You can put them in order, you can put them out of order, does not matter to me. All right, we're going to end with some actual algebra. So at the very end of this handout, you have some algebra that you're probably familiar with. And all you do is plug in the x value to the expression. This isn't an equation, it says to evaluate. So we need to plug in the 5 and simplify, or in this case, evaluate. If it requires plugging in, solving, something like that, I need to see at least one step of math. I realize you can do this in your head, but I need to see one step of math. And we get 38. Maybe try 7 and 8 without me. Hit pause, wrap those up. All right, number 7, we're going to square a 6. And we get 36. Be careful, that's not 6 times 2. Let me back up. That's 6 times 6. So be careful with that. Common mistake to multiply times the exponent. And we get 66. Let's plug in the 9. So go in small steps here, easy to mess up. And finally, we get 21. All right, last thing I'll say, you maybe have never seen this before. You have an assignment, but it's optional in Classroom. So if you click on classwork, you have some practice problems here. When you click that, it shows you the problems that you would need to do to get that extra credit. The document, of course, is right there. But I want you to do those 7 problems. It's extra credit, that's all. And it's due Wednesday this week. If you want to turn it in, you need to work them on separate paper, take a picture, and upload it. And you're good to go. All right, see y'all in class. Bye.